So since we use both radians and degrees to measure angles in my higher course, it's going to be very useful to be able to change backwards and forwards between them. So if you're given an angle in degrees, you might want to be able to change it to radians, and if you're given it in radians, you might want to be able to change it into degrees. So let's have a look at how we do that. Well, we're going to use the simplest exact link, which we saw just a second ago, between radians and degrees. So 180 degrees, or half a circle, is exactly the same as pi radians. That's both the same angle. So if I was to take an angle like 120 degrees, and I wanted to turn that into radians instead, then what I would think of doing, is how I remember it, is I want to bring pi into it, because most angles measured in radians have pi featured in there somewhere. So I've brought pi into it, and the only way I can balance this out, I can't just go multiplying by pi for no reason, is if I also divide at the same time by something which is exactly the same as pi, and that is 180 degrees. So I've not changed it, because as I'm multiplying by pi, I'm also dividing by exactly the same thing given in degrees. So what happens here? Well, first of all, we can do some cancelling. These are both in the 60 times table. 60 goes into 120 twice, and 60 goes into 183 times. And that leaves me with my answer. 2 times pi, so 2 pi on top, divided by 3. And there we go, 120 degrees in degrees is 2 pi over 3 in radians. Let's try 60 degrees. Now this one I'm going to do slightly shorter. Often I just skip that multiply sign and I just sandwich a pi sign here. I'm doing exactly the same thing, but just skipping the time sign, and I put 180 underneath. So I'm still timesing by pi over 180, but I'm just putting it right in there. Now, I'm going to do the same thing. I'm going to cancel. These are both also in the 60 times table. So it goes in here once, and here 3 times. So 1 times pi, well that's just pi, and over 3. So there we go, 60 degrees is pi over 3. And finally, let's look at a third one. Let's look at 315 degrees. Same thing, I'm going to multiply by pi and divide by 180 degrees. And what times table are these in? Now if I wanted to, I could take it a step at a time. I could divide by 5, and then I could see if I could simplify further. But we might recognise that 315 is in the 45 times table. It's 45 degrees less than 360. So how many 45s go into 315? Well, 45, 90, 135, 180, 225, 270, 315. So that's 7 times. And how many times does 45 go into 180? That's 4 times. So it leaves me with an angle of 7 pi over 4. Okay, so what about changing radians then into degrees? What about if I'm given 3 pi over 2 radians and I want to know what that is in degrees? Well, I'm going to do exactly the opposite. So instead of timesing by pi over 180, I'm going to divide by pi over 180. Let's have a look at what that looks like. Divide by pi over 180. Well, if you remember your dividing fractions work, you'll remember that dividing, the very first thing we do is we change it into a times and we flip this upside down. So what we're actually going to do is times by 180 degrees over pi instead. So we still multiply, we flipped it upside down. So we are dividing by that, but it looks like this. I remember it in a slightly different way. I think of it as, if I want to change radians into degrees, I'm going to need to get rid of that pi sign. Okay, so I'm going to divide out pi. So the first thing I do is put times by, and I put pi underneath, and then I think, okay, again, I need to balance that. I can't just go dividing by pi for no reason. So I've got to balance it by multiplying by 180 degrees. Okay, however you choose to remember it, that's what we're going to do. We're going to divide by pi times by 180. So the very first thing that happens here is these pi's will cancel. They're gone. Now, we can do some cross-cancelling here actually, so we can say, well, I'll divide this by 2, and I'll divide this by 2, and we're left with 3 times 90 is 270 degrees, and actually underneath we just get 1 times 1, which is 1, so we don't even need to write this as a fraction. That's just going to be 270 degrees. Okay, let's try a couple more. Let's try 7 pi over 6. So, same practice. We're going to multiply by 180 over pi. And first of all, we'll cancel out the pi signs. Next thing we'll do is we will do some cross cancelling. Well, these are both my 6 times table, so that goes in once and that goes in 20 times here. That's not right, 30. So that leaves us with 7 30s are 210, and again here 1 times 1 is just 1, so we don't need to write that as a fraction, 210 degrees. So there we go, changing from degrees into radians and radians into degrees. So let's have a look at a couple of examples involving radians. So first of all, I'm being asked to evaluate sine of pi over 4. Now this will be a non-calculator question, and I'm going to need to know my exact values, but I don't know my exact values in radians. I learn my exact values in degrees. So what I'm going to want to do is turn pi over 4 into degrees. So what I want to do is to go to the side of my page. I'm going to take pi over 4 and I'm going to multiply by 180. I'm going to divide by pi. The pi's will cancel. I can cancel by 4 and I end up with 45 degrees as being the same as pi over 4. So instead of evaluating sine pi over 4, I'm going to evaluate sine 45 degrees. And if I know my exact values, I can check my memory or I can draw triangles. I'll end up with the answer of 1 over root 2. And there we go. Okay, worth mentioning at this point, there are some shortcuts we can sometimes take to get to this answer of 45 from pi over 4. Well, if you remember that pi is 180 degrees, all this is saying is 180 degrees divided by 4, well that's 45 degrees. Okay, sometimes there are slight shortcuts we can take instead of doing this. But there we go. So that was going from radians into degrees. And now we're being asked to solve a trig equation. And if you'll have a look at the limits here, the limit says the x is between 0 and pi. So the very first thing I want to do when I do one of these trig equations is I want to check my limits and I want to see what they are. Now, again, I think in degrees, the first thing I'm going to do is I'm going to change this into degrees. So 0 degrees is just 0 radians. And pi, well, that's 180 degrees. So what I'm being asked to find is solutions between 0 and 180. So I'm now going to go ahead and I'm going to solve this question as normal using my cast diagram, principal value. I'm going to get my solutions and then we'll take it from there. Okay, so I've got a couple of solutions, 60 degrees and 300 degrees. So the first thing I need to do is I need to keep thinking about my limits here. For 2 reasons. The first is that I'm going to need to cross out this 300 degrees. That's outside my limits. Outside limits, oh well. Second thing is, because my question was given in radians, my limits were given in radians, then I need to give my answer in radians, and I would lose a mark if I didn't do this. So what I'm going to do is change 60 degrees into radians. So I can do this outside of my page or I can do it right here. I'm just going to do it here since there's only one of them. So I'm going to multiply by pi. I'm going to divide by 180. I can simplify by 60 degrees. So that gives me 1 over 3 and it gives me a final answer of pi over 3. So there we go. Limits. I tend to change them to degrees, but most importantly, if your question was given in degrees, in a radian, sorry, then your answer should be given in radians as well.